Yesterday we covered the topic about the scheduling of pod to the specific node. And for that, we discuss node port, node selector, labeling, and taint, toleration, and affinity, anti-affinity concepts. So today we have to discuss about the uh, resource limit, how you can limit the resources, CPU and memory on containers running inside the Kubernetes cluster, and the quality of service class concept. So if I go to the Kubernetes documentation, here if I type limit pod resources, so resource management for pod and container. So I can see the resource management for pod. When you specify a pod, you can optionally specify how much of the each resource container need. The most common resource to specify the CPU and memory. So we must have to limit these resources whenever we are going to schedule a pod. Because if there is some bug in the application that is running inside your container, and some memory leak is happening, or some loop happen that is consuming too much CPU, so that can choke your whole node that is hosting that specific problem creating a container. So resource limit is very imperative, and we can limit the resources so far whatever we ran. So let me just quickly power on my cluster. So then it will take 2-3 minutes to boot up. So meanwhile, I will give you the idea from the documentation how to limit the resources and what are the concept of resource limitation and what is the concept of quality of service. So if I go to the same documentation, the resource type, CPU, and memory. Okay, so when we will allocate the CPU, so there is a unit of CPU. We will allocate the CPU in sense of cores. For example, I have a 4-core in my worker node. So each core has 1000 millicores. So I can allocate the amount of CPU core in sense of millicore. For example, 500 millicore mean half CPU core, and 1000 millicore, one CPU core. 100 millicore mean 10th part of 10th part of your one CPU core. So similarly, I can also define the CPU core just like 0.5 CPU core. In that case, I will not define the millicore. So just like it is given here, 500 millicore. If you read this documentation, you can get the idea how this will work. And 1 millicore is equal to 0.001 CPU. Okay, and 5 millicore is equal to 0.005. I mean, how much time the CPU will give to compute frequency will get that specific container from the CPU. So memory resource limit we can do in megabyte and gigabyte and whatever terabyte if we have that amount of RAM. And we can do 400 MI, mean 400 megabyte. Okay. Or we can just type 400 MI or M, we can use the unit. So here is an example of a resource limit. There is a pod running, there is a resource section. So far we set up the resources in our manifest. We just put the curly brackets here, mean unlimited resources. But we can limit the resources by defining the request and limit. Request mean uh, this this amount of RAM and CPU must be available on that worker node where it will be scheduled. Then scheduler will decide based on these values. If that worker node, if that specific worker node comply this requirement, then it will be hosted there. So 250 millicore CPU mean fourth part of your one CPU. Mean two point mean one fourth mean 0.25 CPU core and 64 megabyte of RAM initially, and limit mean when this will be the initial requirement of the application, and when this application will run and it will ask for more memory, it can go up to max 128 megabyte and half CPU core. Okay, so the request is the starting value. So this, with this way we can define the value. So when we whatever container we will define, we have inside our pod, we must have to define the resource request resources requirement for each container. Okay, so there is a concept of quality of service. So let me just drag down. Here we could see let me just do a control F QoS. No, this is not in this documentation. So QoS. Yeah. So configure quality of the service for the pod. So there are three types of QoS classes for the pod: guaranteed, best able, and best effort. So best effort mean when we are not setting any resource limit, it will be the quality of service will be bustable. Best effort. Bustable will be when we will set up the request and limit both for the pod, that the starting requirement and the expansion requirement. And guaranteed is only when we are only setting the limit, we are not setting the request. So we if I go down, so I can show you this is the limit and request is set when I will do the describe to this pod. I will show you the quality of quality of service class granted will be mentioned there. So let me just quickly connect with my cluster. It is up. So let me just ping to my. It's up and it's taking a while to connect. Okay, it's connected. So let me just first of all check my cluster is all the environment variables for kubeconfig are ready. kubectl get nodes. It will take a I think the services are still trying to servers are both servers are up. Taking time. Still, the API server is not up and running. So how I can see CRI PS command, this is my master node. I can see all the containers are up or not. I can see API server, container controller manager running, kubescaler etcd, and let me just, yeah, it is up now. So I will create kubectl run app1 simple pod. I can say the app1 pod. In the dev namespace, I will create this file. And the file name I want to can say the this should be equal. Let me open this manifest and I will add the resource limit here. So under the by default, this resource is unlimited. So I need to set with the proper indentation. So I will get some example from here. resource limit. So request I am setting to 64 megabyte, half 250 millicore of CPU, and the limit is going to 128 megabyte. So let me just quickly set up this pod under the dev namespace. And then we can see the status of this, the description of this pod will show us the QoS quality of service class. So kubectl get pod hyphen dev namespace, and this pod is running. If I do a kubectl describe pod in the dev namespace. So here you can see the QoS class is bustable. Bustable mean when we are setting the request and limit. Okay, let me create another pod in parallel to this pod. You can see this app too. And here I am not going to set any limit, just like the general pod we ran, setting the unlimited resources. And I need to change to this, just change the name, rest of all is good. kubectl -f kubectl get pod dev namespace. The second one is running. Let me do a kubectl dev namespace. So you can see its quality of service class is best effort. So when we are not setting up the resource limit, it's best effort. But when we are setting the resource limits, it's burstable. Okay, now the third one is the this one, the guaranteed. What is this one? So with guarantee, we can create another copy of the same manifest. Application 3, let's see. And let me just change the name. And this time I am not setting the request, but only setting the limit. I mean the what max memory it can occupy and what max amount of CPU, initially whatever the limit is. So when we are only setting up the limit, it's mean the scheduler will look for these resources availability. So third pod is also running. So let me describe this pod tree. And here you can see the quality of service class is guaranteed. To So you can see the limit is automatically set with the value of the request. Mean when your limit is equal to your request is equal to limit, it is guaranteed. It mean what is your max requirement, you are only setting that one. But this is not a good practice. You must have to set request less amount of request, and gradually it will occupy the resources when required to the limit. So these are the three concepts of quality of service, and you can read this documentation for the more information. So this was the topic for this session only. So in the next session, we are going to cover the metrics server and horizontal pod auto scaling. So how when the load on the application will come, how you can do the auto scaling of your pod.